Please remember that the complete information for the class that you are about to view is at elithecomputerguy.com. Not only do we have our videos there, but we have part lists, diagrams, pictures, and even complete code examples. So if you are watching this video and you want more information, please go to elithecomputerguy.com. Welcome back. As you know, I am Eli the Computer Guy, and in today's class, I'm going to show you how to use an ArduCam with an Arduino to store image files to an SD card. This is one of those things where if you know what the steps are, it's incredibly simple. And if you don't know what the steps are, it's a complete pain in the ass, and you will rip the little hair you have left out of your head. So in this class, I'm going to be showing you how to be able to take pictures with your ArduCam and be able to store them to an SD card. So the warning for today is that you use a good data logging shield for this particular Arduino project. So basically we're going to have our Arduino Uno board on the bottom. We're going to have our data logging shield connected to that. That is what we connect our SD card into. And then on top of that, we are going to connect our ArduCam. The important thing for today's project is that you have a standards-based data logging shield that you're going to be using. The problem that you may run into is if you're like me and you simply went to Amazon and you purchased a data logging module that may not be 100% standards compliant. What I mean by this is that the ArduCam uses the I2C protocol in order to be able to communicate with the Arduino board itself. And one of the issues you may run into with your data logging module is that if there are certain things within the data logging module that are hard-coded into the module, then when basically the Arduino boots up and it tries to dynamically assign resources to the different things connected to it, you may run into problems. So basically, I was using this particular data logging module, and I've used this. We have used this on other projects. So this thing does work. It does work with other stuff. The problem that I was running into is when I connected this to try to build this project to have the ArduCam save to this module, what would happen is I would get a FIFO size error. So essentially when the ArduCam is creating the image file, if it is above a certain size, it fails out because obviously you don't want the image files to be too big. And when there was a weird problem where how the communication was happening, essentially I would continuously get FIFO size errors because of this particular module. Did a lot of research, tried to figure out what the hell was going on. I figured, oh, maybe I put in the wrong pin number, maybe I did something wrong. And apparently, if you go and you do a good bit of research on it, apparently there is something hard-coded in this particular module. And so when you try to connect this and use it with an Arduino, with a ArduCam, essentially it just fails out, right? So basically the standard is whatever the hell is hard-coded in here is not supposed to be hard-coded in there. So initially, to make this project work, I actually went and I simply used an Arduino Ethernet shield. So this is a standard Arduino Ethernet shield. This is actually from Arduino itself. And on this, it happens to have a micro SD slot, again, for data logging functionality. And what I was able to do is literally, I spent like an hour trying to make this thing work, kept getting the FIFO errors. Then I saw that there was a problem. I was like, I'll take this. I slapped this on. All I used was a data logging component, and literally I had the project working in about 5 minutes. Once I was able to get it working on this, I then simply went out and bought a clone data logging shield from HitLego. I actually like them as a vendor. I slapped this on, and again, this is now working. So my ArduCam is able to save images to the SD card that is in the slot. And so the big thing is if you're going to try to do this project, make sure you get a standards compliant SD shield. Literally, it may all simply come down to if your little data logging module doesn't like to play nice with the ArduCam, no amount of coding that you're going to do will make it work. Or at least any amount of coding that I'm going to show you how to do in these particular projects. So the big warning for today is go buy a good data logging shield for your project if you're going to be using the ArduCam. Make sure everything works that way. And then once you make sure everything works that way, then you can go out and try to experiment with other things. But literally, right? If you get an SD shield that is not compatible, none of this is going to work. The only other warning for the code that I'm going to be showing you today is for the SD. So the SD has a CS port, and so basically we're going to be using digital pin 10 today. So for these shields, when you have a shield, you don't actually know what things are connected to what. So you're not necessarily sure what digital pin the SD card is connected to. So again, you can go and do a little bit of Google research, and what you can find, again, by standards, is that the SD card on a shield is connected to digital pin 10. So one of the things you may have to do is for the SDCS pin within the code, you may have to modify that to 10. So those are just two of the things to keep in mind. The big warning is just make sure you get a data logging module that will actually work, and then beyond that you may have to change the pin assignment number within the code to make this functional. That is literally all I really had to modify today, other than one of the configurations in the memory file. So with that, let's go over, I'll show you on the Workbench basically how this is all connected up, then I'll go and I will show you the code. So here's the basic setup for the project that we have today. Again, so we have a standard Arduino Uno board, and on top of that we have this data logging shield. This particular data logging shield is from HitLego, but basically any standards compliant data logging shield will work for you. Again, I initially did this project using the Ethernet shield that actually has a micro SD card slot built into it, and so this project works completely fine with this. Again, you need that standards compliant SD card or micro SD card in order to be able to make this work. This is the data logging module. To be clear, I have used this data logging module to work on other projects, again, for things like temperature sensors, other types of sensors, and it works completely fine when you're dealing with normal analog or digital sensors, but for some reason, when this is trying to communicate with I2C and SPI, it basically fails out. So do be careful. This is one of those times where literally the product you use to build the project may be whether or not the project succeeds or fails. One of the things to be thinking about whenever you do go out and you buy your data logging shield, as long as the data logging shield is standards compliant, so it works with I2C and SPI, so on and so forth, the other thing to think about is you can get different functionality out of the data logging shield that you're using. So obviously this has an Ethernet port to it, so if you want to create something like a web server that's able to take pictures, you might use something like this. One of the things I like about this particular HitLego shield is it actually has a real-time clock mechanism on here. So what you can do is for things like naming the image files, you could actually pull the name as whatever the current timestamp is. So again, something to be thinking about with your Arduino projects is if you need a shield like this. So the primary purpose of the shield is for the data storage, but on top of that, you might look and see what other components are available. Simply having something like a real-time clock built directly onto the shield, that can be very useful, again, for doing things like timestamps with the image names. Beyond that, basically, again, you have the shield connected directly into the Arduino Uno board. One of the big things with this is when you're dealing with a shield, do make sure you have the SDA and the SCL ports that go all the way through the shield, so you can connect your ArduCam to the SDA and the SCL ports. Again, some different shields. So again, so this shield right here, again, is an Ethernet shield, but this is a SaneSmart Ethernet shield. This also has a micro SD slot on it, but I don't know if you can really tell from up there, the pins, it does not have the SDL and the SCA pins coming up through. So that's one of the reasons I didn't use this for the particular project. So one of the things you want for the shield that you're going to be using is that the SCL and the SDA pins actually go all the way through, and then you can connect to the top. Past that, again, you're going to connect 5-volt VCC, you're going to connect your ground, you're going to connect your SDA and your SCL, then you're going to be connecting to pins 11, 12, and 13 based off of the diagram that ArduCam will give you. And then there's a pin for the actual picture itself. So you can actually connect multiple cameras to your Arduino project, but then have them be triggered by different digital pins. So basically what you can do is you can split these off. So basically you can split these off to have these connect to multiple different cameras, but then the actual image file itself, when it comes in, that will be triggered by whatever digital pin you connect this final pin to. So for this is actually going to pin 7. So within the code, you could actually code for multiple different different pins. But that's something to deal with a different project later. That's a little bit more complicated. Again, in order to connect all of this, you essentially look at the diagrams that ArduCam gives you and basically slap it all together. The big thing is that the SDA and the SCL go all the way through. And other than that, that's basically what this project looks like. So let's go over and take a look at the code itself. Okay, so to make this project work, there are going to be a few things that you're going to need and you're going to need to know. So at ArduCam, ArduCam.com, that's where you can get information about the ArduCam. One of the important things is you are also going to need to get the ArduCam library. So they have the library available. You can download it, and basically all you have to do is then copy and paste the library that they give you into the Arduino libraries folder in your document directory on your computer. So the first thing you're going to have to do is actually download that ArduCam library. The next thing is you're going to need to know the information for your particular camera that you have. So if we go over to ArduCam products, we can click on ArduCamera, and what we can see is that there are a few different versions. There's a 5 megapixel version, there's a 2 megapixel version, so on and so forth. So basically what I have is I have the 2 megapixel version, and so the two things that I'm going to need to know is I'm going to need to know basically the name of the camera. So I have an ArduCam 2 megapixel plus. I'm going to need that information, and then I'm going to need to know the mini module information. So this OV2640, I will show you where you're going to need that in the configurations going forward. So you will need to have this information. This isn't simply a plug and play. Any ArduCam will work. You do need to know this information for the configurations. Past that, again, for this data logging project, you're also going to need to verify what digital pin your particular shield uses for the SD card. So I went here to Adafruit. So the Adafruit is basically the design that this particular shield is based off of. And so for the CS pin that we're going to use, that goes to digital pin 10. Again, in different on different shields, that might go to a different digital pin, and you may have to configure that within the actual sketch itself. So with that, let's go over and take a look at the code. So here we are taking a look at the code. The demonstration that I'm going to show you today is from the examples. It's the ArduCam Mini 2MP plus multi-capture 2SD example. So if you go to File, you go to Example, you go to File, you go to Examples, you go down to ArduCam, you then go to Mini, right? So there's a whole bunch of different versions here. You then go to Mini. Basically what we're going to be doing is we are going to be using this particular example right here, the ArduCam Mini 2MP plus multi-capture 2SD. I will tell you that's one of the big problems with what I find with ArduCam is they give you so many options. They make things very difficult to figure out exactly what the hell you're doing initially. So again, that's one of those that once you figure it all out, it becomes very easy. Again, it is important that once you download the ArduCam library, that you then store it within the Arduino folder in your documents directory. So in libraries, you can come here and basically you can see I've saved this ArduCam library here. Now within this library, there's going to be a configuration file that you're going to need to modify. There's this configuration file called memory saver. So the memory saver file, you do have to configure for your particular ArduCam. So if you open this up, you can see that there's two steps. So step one, select the hardware platform that you're going to be using. So basically here, what you do is you basically uncomment out what you're using. So I have the OV2640 Mini 2 megapixel plus. This is a particular camera that I'm using. You can see that there's a 2 megapixel, a 3 megapixel, 5 megapixel, 5 megapixel plus, so on and so forth. So this is what we're using, or at least I'm using. So I uncomment this out. And then down here, you also select the camera module. So again, as I said before, I'm using that OV2640 camera module, and so I uncomment that out. Again, it's important to see that they have a whole bunch of different camera modules here. So there's different cameras, there's different camera modules. If you don't do this properly, you will run into issues with your code. Once you're done modifying this as need be, you can then simply click save, and once that's saved, you should be good for dealing with the rest of your sketch. So let's go and take a look at this particular sketch. So we take a look here. You have a lot of stuff that's commented out in the beginning, just gives you a lot of information about the sketch. And then we come down here to the actual libraries. So we have the wire library, SPI, and the SD library. Those should all be within your Arduino IDE by default. And then the important thing is you're going to need that ArduCam library. Then past that is this is that configuration file that we just dealt with, memorysaver.h. So basically this, the memorysaver.h file, again, it's going to come here and it's going to grab the information about your camera and your module. If you do not configure that or you configure it properly, if you go through and you try to compile this sketch, it will fail out and it'll tell you that there's a problem. You're going to come down here. There's a whole bunch of different information defining frame number, a whole bunch of different things. CS, so the const int CS. So this right here, this is important. So this is for the ArduCam. Remember where I showed you that wire? So if we go over and we take a look at my at the actual physical thing. So this is for this digital wire here. So again, each one of your ArduCams that's going to be connected to the Arduino, that will have its own individual CS pin. And so for this, that's the CS pin 7. So you could change this for some reason. If you had an ArduCam on a project where you had a bunch of different devices already connected to digital pins and you wanted to use this on digital pin 2 or digital pin 3 for whatever reason, you would modify the CS within the sketch. But it is important to understand that when you're taking a look at this CS, this is the CS for the ArduCam itself. If there isn't a reason to modify it, just leave it as is and connect the digital pin like normal. Then the SDCS, so define SDCS, so this is the digital pin your SD card is going to be using. So that, if we go over and we take a look at the documentation, so this here is a documentation for that SD shield, and so we can see the CS for this particular SD shield is pin number 10. So again, if you're running into problems for some reason, do a bit of research, make sure you're connected to the proper pin. So that works. And then past that, basically that's the only thing you do to modify the code. There's a lot of code in here. And again, you can basically go and take a look at it. But a lot of this has to do with basically, again, an Arduino does not have a lot of what you would call computing power. And so a lot of things that can be accomplished in the normal computing world simply with a single line of code takes a lot more to accomplish in the Arduino world. So if you're taking a look at this is everything that's required in order to basically take the image out of the ArduCam and be able to save it to the SD card. So with that, what we're going to do is I'm going to plug the SD card into my little ArduCam project. So the SD card is in, it's connected to the ArduCam project. We are then going to connect this into the computer, and then what we can do is we can go and we can take a look at the serial monitor. So if we go and we go up to tools and we take a look at the serial monitor, this is where we're going to get some diagnostic information. So let me point the camera at myself so we can start taking some images of myself as I talk, and we can take a look at this in a second. So basically what we have here at the top is ArduCam start, SPI interface OK. So if there's any kind of problems with the ArduCam itself or the SPI, you may get some errors here, but we can see that that's okay. ACK command, so the OV2640 is detected, so that's the actual module on the ArduCam itself to make sure that's detected. The SD card is detected, so if for some reason the SD card is not detected, it'll fail out there, and so then it's going to start to capture. Then it's going to say the capture is done. Then it's going to tell you the total time. So it took about a second, slightly over a second for the capture, and this FIFO length. Again, if you start getting FIFO length errors where it's too big, that most likely means you have a problem with your data module. And then basically it's just going to continue to do this. And for this particular project, every few seconds, it's simply going to take a picture, save that to the SD card, and keep going. So there's no triggers on this. It's not triggered by a motion sensor. It's not triggered by anything. This is simply waiting. Again, it waits for about 5 seconds or so, and then it takes a picture and just keeps it taking a picture, takes a picture, and it keeps taking a picture to the SD card. So with that, what I can do is I can simply pull out the SD card. So you can, it's not a computer, you can pull out the SD card. What I'll show you though is when you pull out the SD card, that's where you'll get this file open failed, and then you'll start to get failures basically that it can't read that the SD card is there. So let me, if I reboot, and so it won't be able to continue on. One of the things that I will tell you is, see, you get the SD card error there, so keep getting the SD card error. One of the things that I will tell you is if you pull the SD card out and then you put it back in, restart your Arduino. That's an important thing to understand. Restart the Arduino. If you don't restart the Arduino, most likely it will not start saving files to your SD card. So with that, let's go over to my little demonstration computer. I will then slot the SD card into the side of the demonstration computer, and then we can go and we can take a look at the high quality image files that we get. So again, the untitled card shows up, and then we get all of these image files. Ooh, look how pretty they are. Again, you start to realize that 2 megapixel image files may not be quite as impressive as you thought they were, but you know, now you can see that our little Arduino project is actually able to take pictures, and so as it goes through, it's just continuously taking all of these different pictures, and you can see. One of the things, again, one of the warnings to be thinking about and why that real-time clock is significant is you will notice the naming convention by default is simply basically counting up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so on and so forth. One of the things you do have to realize is, remember, is when you restart the Arduino, it will restart the numbering process again. So if you have a bunch of pictures taken with your ArduCam and then you hit restart, it will start overwriting. So if you already have an image file called 1.jpg, when you restart, it will overwrite 1.jpg with a new 1.jpg, with a new 2.jpg, so on and so forth. So this is one of the things where having something like a real-time clock can be significant. So when you start doing more complicated projects, you do a naming convention based off of a timestamp, so you don't have the ArduCam continuously trying to overwrite image files that are already there. Again, just one of those little warnings to be thinking about. So that's really what there is to using the ArduCam. Again, if you set it up properly, it's relatively easy to get set up and running, and if you don't, it's a horrible, horrible thing. So there you go. Now you can have your ArduCam saving image files to your SD card. Again, if you set it up properly with a standard compliant shield, you'll do okay. If you use a non-standards compliant shield, it's going to be a lot of troubleshooting that will be no good. This is one of those perfect examples. This is one of those perfect examples where literally spending the $6 for something that's standards compliant is just so worth it. It's like, what? I could either troubleshoot this for the next 5 hours, or I could buy what I really need to have and get it working in a couple of minutes. Kind of one of those things to be thinking about. So again, if you're going to be doing this project, do make sure, because this uses I2C and the SPI in order to be able to communicate, and so for that, the Arduino needs to be able to communicate in specific ways. If your SD card, your capture device, doesn't allow that to happen, you can run into problems. You will most likely get that problem with that FIFO length error if you see that. So just keep that in mind. Beyond that, when you go to configure this, again, do remember with these shields, or if you find a compliant data module, it will have a specific CS pin number for communicating with the SD card. So I think by default it's is 10, but again, in the sketch, when you initially open it up, I think it defaults to 9. So you may need to modify that within the sketch, and you may need to modify that going into the future if you use a different shield that for some reason uses a different pin for the CS. Again, also as far as the CS goes, pin for the ArduCam itself. Again, I have this connected to pin number 7. That's the default for this particular project. You could have this connected to different digital pins on your Arduino project. Basically, you just have to then write that into the sketch. And why that's useful is that you can actually have multiple ArduCams connected to a single Arduino, depending on what type of thing that you're trying to accomplish with your project. Beyond that, you go into that little memory saver configuration file. Again, it's important that you know what camera you have and then what module you have on the camera. So essentially, when you buy it, You'll know what you're buying. Is it a 2 plus? Is it a 5 plus? Is it a whatever? And then again, when you buy it, it'll tell you what that module is. And so you go into that configuration file, you say, this is the camera that I have, this is the module that I have, and away you go. If you configure that properly, it works fine. If you don't configure it, it doesn't work. It's pretty simple. Then beyond that, the only final thing, if you are actually going to be using this project in any kind of real world scenario, is do realize the default naming convention is simply 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Basically, that is simply an iteration. So basically, when you turn it on, the first picture it takes is 1, the second picture it takes is 2, and the third picture it takes is 3, so on and so forth. So every time you reboot your Arduino, it will overwrite the pictures that it has taken before. That's why it's important to be thinking about something like having a real-time clock component, so that when you actually start building projects with the ArduCam, you can have the naming convention based off of a real-time clock timestamp, so that you don't run into overwriting situations when you don't want to deal with overwriting situations. And past that, then you can just start playing and see what you can do with this. Again, you can do, I've already created little motion sensor projects with this. You can create like time lapse projects. So right now, again, it takes a picture every couple of seconds or so. You can actually delay the code, so it only takes a picture like every minute. So if you wanted to set this up and then it'll take a picture every minute, and then you can get some time lapse over a week or something like that. There's a lot of interesting things that you can do with the ArduCam once you get this initial setup, which again, the initial setup is more difficult than it needs to be. If you have any issues, go over, take a look at the ArduCam website. Again, their documentation isn't the best, but if you take a look at it for a while, you'll probably figure out what is going on. So anyways, that's really what there is to the basic setup for the ArduCam saving to an SD card. Go play with it. As always, I enjoy doing this video. I look forward to seeing you on the next one. If you like the content that I create, please think about going to elithecomputerguy.com and becoming a member or donating. Please understand that all of the educational videos are in front of the paywall. That includes the videos, that includes the notes, the diagrams, and the code example. All of that is freely available and in front of the paywall. But if you want to watch opinion videos, or if you want to be able to comment, you do need to become a member. Membership is $5 a month or $60 a year, and gives you access to those opinion videos and the ability to comment. If you don't want to become a member, you just want to give a one-time donation, there is also a donate button where you can do that. Please understand, in order to provide the education that I am, it does cost money. Servers cost money, equipment costs money, travel costs money. All of these things cost a reasonable amount of money, and the fact of the matter is YouTube's advertising program no longer supports creators the way that it used to. So if you want these classes to continue to stick around and you find them to be valuable, please think about either becoming a monthly member or donating a few dollars for this project.